preparing individuals for the social setup, current social setup. So current social setup and its economy is what matters generally. So that is what we saw in the last class. Any questions so far on that? Okay. So today we are going to talk on session 4. So we will dive into early science, right? How science evolved. So all this religion, economics and all are one side of it. But human progress, if you measure it, it took great leap when there is a new inventions and discoveries, right? So, so science played an important role in moving forward, especially after the physical evolution, when it's replaced by cultural evolution, right? It jumped. Human progress started going forward very quickly, and invention of agriculture is again gave a big boost to the human progress. So what made that possible? So early science, if you see, it's all based on. It is not institutionalized. It's all based on the need, right? So if you see this one major, of course, invention of wheel and all, we always talk, but one of the major thing that they talk about, the anthropologists talk about, is the invention of bow and arrow, which is not just used to kill animals, but it also used to um, boring. I mean, making hole. If you see this device, it's say if you have a small twist here, and if you move this side, that side, it will create a rotary motion, right? Rotational motion. So linear motion into curve and rotary motion is one of the major things. Of course, there are a lot of small things we can keep talking, like using stone as a tool and the invention of wheels and all. But what we are here going to discuss is to see some of these devices which are very important and considered according to the anthropologists. So this is one bone arrow, and these devices, same using bow, you can also drill things, and you can create fire using this thing. I mean, move this and create a rotary motion, which will create a lot of friction, and um, it can be used to create fire, right? So that is one of the major invention. Um, let's move on. Of course, nature also inspires um, a lot of inventions. So they try to mimic nature, right? We ourselves see, um, even today we get inspired by nature and try to make tools like that. So in the olden days, sickle is something, they say that it's inspired by jaw of sheep, because they see that, okay, sheep can cut the leaves and eat without any problem. So with that, they try to make a tool out of it. That's how they say that the sickle got discovered. And of course, from the crocodile tooth, also they would have seen something and invented the saw. So this kind of science based on the just inspired by nature, how nature is doing certain things and trying to mimic, right? So of course, so agriculture pushes you further, counting the livestock. Like I have some, say, 10 cat, 10 goat or sheep, or cow, I should be able to count, right? Whether when I take it out and when I come back. So in the olden days, they say that right, when you have a small pot, and in that pot um, you put a stone. When you take a cattle out, one cattle out, you put one stone. Another cattle out, you put another stone. When you bring it back, you remove one by one. If the pot is empty, then you know all cattle I have brought it back. Otherwise, you know that there is something that's missing. So that's how the counting gets started. So livestock brings in the counting process, and then it slowly got into number theory. So observing the sky, when you want to do agriculture, one has to see, understand the rain cycle, right? So observing the sky was an important part as part of the agriculture. So astronomy got triggered, and then of course land measurement is important. That also got mm, gave path to geometry. In the olden geometry, if you see Euclid geometry, it is more about squares, rectangles, circles, and all, right? So those kind of geometry to measure the land and restrict the area, all those things. These measurements also got started, and of course, plow, lever, and all to make the to it's very important to till the land and move the huge rocks. All these devices are coming into existence. So science takes a major leap forward, and they slowly they started systematizing. So far, if you see all these discoveries of these tools and all, there is no specific name associated with these inventions, right? They are all like somehow came into existence. Independent people might have done it. Some people would have taken it, refined it. Continuous refinement could have make it perfect, but we don't have a name associated with it. But going forward, slowly, we started seeing the way of doing science, right? That also getting systematized. So we already saw in last class that agriculture gave extra food, and people could specialize, right? They don't have to work just to get food. They can do something else. So specialization like carpentry, weaving, all these things started coming. Similarly, people specializing in science also started coming. So how about so the naming of scientists or associating a theory or invention to a particular uh, person, right? So that's all started appearing. So we are talking about here 8th century BC. One of the earliest documents is all um, available is the Upanishad, and there are other uh, documents as well. But the earliest name that we come across seems to be the name called Uddalaka Aruni in the Chandayogya Upanishad. It dates up around 8th century BCE, that is before Common Era. Mm, So what this guy claims is that if you see that it is beyond now just numbers and astronomy and all, they started talking about what things are made of, right? So Udalakarani says that everything is made of heat, water, and food, right? Heat, water, and food. So there may be reasons for them to believe that, but um, what we are trying to discuss here is, okay, there is something called um, a special set of people started asking questions like this, like what we are made up of, how the heavenly bodies move, all this. I mean, this is a little bit more than the basic needs of food, right? So if you see just previous couple of slides, the science was just to make sure you are killing or your basic needs, right? Now it slowly deviates from that, and it kind of going into more than basic needs and going into some fundamental questions like what things are made of. So, and also that way of doing science is slowly changing. In Indian geometry, I mean, the area where we call India now, I'm carefully using the word because India is the name, was not existing at that time. So in this area, the science is in the form of debates, right? The kings will organize debates. Uddalakarani or some people like Yagnavalkya, this kind of people go and debate in front of the kings to arrive at the truth. So this kind of debates based science was on that is popular in this area. And of course in Babylonia, and that's the current Iran also. Astronomers in the 8th century BCE, they developed empirical approach to astronomy. That means like you started calculating the solar eclipse, lunar eclipse, all these things based on numbers. They started appearing in this time during in this area. If you see um, any time, any particular time period of time, if you see there are one particular area geographically popular for science, right? Then it shifts. That's how history has moved. Why I am telling that is, um, some people will come and say that, oh, okay, we did everything. See, in the 8th century BC itself, we have talked about what things are made of. We invented atom, all this glorifying past. Please be um, don't fall to this. Okay, it is very important to know that progress has been made and shared by people, and it happened in a particular geography for some time, and it moved for various reasons. For example, because of some famine, that area itself got destroyed, and people would have migrated. They lost their touch with science, or the basic survival itself becomes questioned. So they moved on. Right. Similarly, some king would have come, rules have changed, then it becomes difficult um, uh, to talk openly about science and all. So that's also caused some way of moving from one area to another, right? So so yeah, so please appreciate, understand it clearly and appreciate that no one area only contributed to science. Different areas in the earth contributed to science as in a different time period. Okay, when Indian subcontinent were doing it, Europe was all silent. They were still probably hunters and gatherers. So one of the earliest scientists again, I call it as the social scientist is Buddha from 5th century BCE. He talked about everything is flowing, right? Buddha didn't say in the form of science, but the way Buddha discussed it, that when, I mean, in his theory of dukkha, right? So he talks about why people have dukkha. Dukkha is suffering, right? Why people have suffering? Because people think everything is permanent. There is nothing called permanent, right? Called permanent. Or nothing is permanent. Nothing is permanent, right? So we think that it's permanent and then we try to attach to it maybe a material thing or maybe to our own self. but there's nothing permanent. Everything is flowing, right? Everything is changing. So that is something that is one of the major philosophical insight that was brought uh, by Buddha. And he also say, not just he gave a philosophical insights on how to see the world. Buddha also revolutionized. I mean, he rebelled against the social hierarchy, right, which was prevailing during the Vedic culture, where the Varnashrama Dharma was preventing people from to go to temple and all. But Buddha's sanghas were allowing everybody to become member, including women. Right, that was a major um, uh, what to say, a step forward towards social side and in the social science way. I mean, in that area, right? So Buddha, in that way, can be seen as a scientist or philosopher and a social scientist at that time. So India at that time was probably a center for science, and not only India. If you see at that time, almost during this period, we have Pythagoras in uh, Greece, right? So Greece was not like a small country now. It was a huge area at the time, but lot of nice development was happening. So 5th century BC, tales from Greek science, tales is one from 5th century BC talks about everything is made of water, right? If you see Heraclitus from same period talks about everything is flowing. If you see probably science communication was there between India and Greek. I don't have any document for this, but from what you are seeing, flowing, the idea of flowing from Buddha and Heraclitus are things, what things are made up of, the question of how things are made up of, these kind of questions people commonly debating. So there's kind of probably kind of communication between or exchange of ideas between these continents might have existed. I don't know. So interesting to see further. We still call it pre-Socratic because Socrates in way gave a new way of looking at it. But till Socrates comes into picture, they call it pre-Socratic science, especially when you consider Western science, which originates in the Greek geography. Democritus, who lived around this time, um, one who first proposed atomic theory, which talks about everything is made of atom. And again, of course, at that time they did not have enough equipments to see what atoms are, how they are made. But something in the Greek term, atom is means something it's indivisible, right? So that kind of again, if you see how in what I mean how things are made, what is made of, that kind of question keeps bothering people. It is not just recent things; it has been there for a long time. We are still struggling with this question. This is a second. There's another. I think we will talk about it later. But it's a very early questions on how things are made of, what things are made of. The questions are there. So one of the major, another important thing is at that time is Pythagoras. Again, almost from the same period or contemporary of uh, Buddha and Democritus. So they started abstracting, right? They talked about universe is made of whole numbers. So they started seeing things in numbers. So spheres, they see that sphere, circle, everything is going around, observing the astronomy. It's all nice, beautiful way of moving things. So they see that, okay, it's all numbers. And it is a kind of obsessed with the harmony of numbers, eh? Harmony of numbers. That's how Pythagoreans started seeing the world. So they also invented, okay, with this string, you vibrate the string and produce music theory. All these nice things came up during this period in Europe, I mean in Greek science. But one of the major thing is harmony with numbers. So of course, we will see Galileo a little later, how Galileo also talked about not just numbers but mathematics um, in a great way of describing nature. But here, if you see, they are completely obsessed with the numbers, and then they were almost always with whole numbers. Even if there is a slight deviation from whole numbers, they were all okay with the fractions, right? Fractions are nice, okay, but universe is made of whole numbers was one of the major idea during Pythagoras. Okay, so it's all fine. You may wish whatever you want to, but nature is always one step ahead or beyond our imagination. So that happened to Pythagoras as well.
Just to add,
Uh-huh.
in the Pythagoras approach, like you said, the harmony, it's another way of saying the fractions itself. Like the harmony is just like one is an integer multiple of the other, kind of. They
Yeah.
match somewhere.
Mhm.
So naturally, they accept ratios,
Correct. Yeah. Yeah.
which becomes fractions in one of the viewpoint.
Okay.
So
Oh,
that's
okay. So even whole numbers they accept as ratios.
yes, correct. Even whole numbers are even 5 is 5 by 1.
Okay. Okay. Okay.
So that
I
way
think
they.
also there was the connection between music, that because when you play a string of music and you stop it at any arbitrary point, then you have like a ratio of the string and they have like its own harmony. So I think
Okay.
they believe that there was celestial harmony in the world, like the
Yeah.
distance between everything.
Uh-huh. Excellent.
True that. So the harmony word takes nice mathematical forms, all these forms. Just not in that.
Yes. Yes. Yeah. Yeah.
Yeah, fine.
Yeah. Thank you. Thanks for pointing it out. So of course, nature is not always as we wish. So so you always know that we all know that Pythagoras this theorem, right? Right angle theorem, where square of hypotenuse equals square of other two sides. Right, but what happens if it is a square? So you have one unit, one centimeter or 1 millimeter, whatever maybe it's 1 unit, and then the side will become say this side is what will be, say let's say x, then its square becomes 1 square plus 1 square, which will be of course 2. So it is 1 square is 1, 1 square is 1, it becomes 2, x square equals 2. So x is equal root 2. Right? Root 2, how do you calculate root 2? If they try to calculate, it goes on and on and on, right? The digits keep on adding. You will not, it's not a fraction or it's not a ratio. It's something that never stops. And similarly, there is this circumference to diameter ratio, right? We all know that the value of pi keeps going on and on and on, right? So it becomes something called irrational number. It's just a random number, right? This, if you see that name, it
An irrational means it cannot be represented as a ratio.
exactly okay, yeah, yeah. So it becomes a continuous number which cannot be. I mean, they couldn't comprehend it. So they are little averse to these numbers. And there is one more number. Of course, they were little really upset about this is 0, right? Because during this time, okay, I'll probably go to the next slide before talking about it.
Just once again, just the fun part is even now we use the word irrational to say something somebody is illogical.
Correct. Yeah,
So
that's
it
what.
stems from this thought process.
Yeah, that's what. How a number can be rational, right? Number.
Actually, rational. There's a ratio in the term. So actually, rational derives from the word ratio and not actually rational meaning capacity of mind. Rational
That is
actually derives
true.
from only the mathematical term of
But
That is the
we
evolution of rational. But then the evolution of using the word irrational for something illogical came from this because they thought
yeah.
yes, yes, yes,
those
yes.
things. Yeah. That's what I do. Yeah, right.
And also imaginary. Same thing for imaginary. It's like an insult. Oh, what is this imaginary number?
Yeah,
True,
yeah.
true. Yeah, right.
Nice. Thank you. So we will come to 0 a little bit later. So Socrates, from that time, almost during that time period as well, he had a way to doing science. So he had something a dialogue-based approach. So what that means is Socrates will take a stand on something and he will argue. And then once he could convince the other side, he will exactly take the opposite side and start arguing, trying to convince. So you might have heard about this dialogue-based approach already, but I when I read about it, it was really fascinating. That so how do you take? See, if you are from one side, if you have argued and convinced, you might have seen only from that side, right? So how do you see from the other side? So you take the other stand and try to find the truth. So that's how he used to arrive at the truth. And so there's a new kind of logical debate and argument and dialogues to do the science. So that's why it's called science after Socrates. Yeah. So that is a approach Socrates gave us. So Plato is a contemporary of Socrates, takes Socrates' ideas forward and took it to the took it to this later scientist like Aristotle, who is Plato's student, and he talked a lot about things in natural science, philosophy, economics, politics, and psychology and arts. So I don't want to go deep into Aristotle's contributions because um, we are anyway going to talk about it little later, what Aristotle said and how Galileo uh, 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 try to defend, try to refute these arguments and all. So, but Aristotle did made a document on various these scientific and philosophical ideas. But what was not existing at that time is who will verify and what will they will do. So it's all based on just based on authority, right? Aristotle was a great authority, great. It's a knowledgeable person. So Aristotle says you take it and believe it or accept it, right? So that is how science was carrying on. So of course, further we go into and Pythagorean trend continues. Euclid is one of the earliest mathematician. He documented all these discussions of Pythagorean geometry into a 13-volume book called elements. So apart from these elements, Euclid also talked about optics, right? Optics also started coming. So how we see things, right? What is light? All these questions started coming. And if we see this from the earliest times, we can see that, okay, how do we see things, right? We all thought that the eyes send some rays. I mean, in that period, Euclid's proposal is eyes send some rays, and that rays gets reflected and comes back to eyes. That's how we see these objects, right? So that was a proposal on optics, one proposal that came, and this is a painting that was done in 17th century by some artist based on what Euclid described in his documents. So this is something that that you can relate. 1 minute. I am just seeing some message in the.
No, sir, it's okay. I usually just like to share something. I'll explain it later.
Oh, okay. Thank you. Yeah. Okay. So if you see, we also see that in Tamil we say that kanpattidichu, meaning they say that if somebody is jealous about others' development, they say that if something comes from our eyes and hitting that. So this is all based on the very, very early idea of optics, which will be later refined. We'll talk about it. So I'm just giving the set of things which is these ideas that's going to haunt the scientific society, scientific community, and it's going to change a lot as we go further deep and deep in the science. So I have only selected these ideas related to what is very, very common in our day-to-day activities, and then try to take it forward. Okay, if you see something is missing, please point out. So it goes on. One of the earliest scientists, of course, we have Archimedes again, comes from Greek, so around the same in this period, and he's done a lot of work. You might have known about Archimedes, how he talked about this finding the volume of that crown of a crown of the king, right? And the amount of gold mixed or not, he discovered. So based on the buoyancy principle, he found that, and he ran naked to the court or to the king's palace, shouting "Eureka!" Right? So he set a tradition. Even today, if somebody invents something, they tell that word "Eureka!" Right? So this guy is another serious inventor in various mathematics, physics, and inventing different devices and all. So the Greek continues to do it. A lot of philosophical and inventors coming up with physics and mathematical ideas. Of course, chemistry and biology and all developed, but I don't know much about it. I'm more into this engineering background, so run this. My interest lies in these areas. Okay, so please don't think that only physics and these areas got developed. So continues. There is an excellent library was set up in Alexandria, probably the first state-sponsored, built around 3rd century BCE. So it is actually burnt down later, but we can still see this this place. The archaeology has uncovered this area, so we can still see it. But Greek was at such a peak where a lot of invention discoveries happen. People, I mean, the state itself recognizes and they contributed to form a library, and so slowly science become institutionalized. So continuing, so Ptolemy around that 100 Common Era, again from the same geographical location, came up with this astronomical calculation and gave a picture of how celestial orbits revolve around Earth, right? So it is very easy to, I mean, at this point of time, now we can say that it's easy to tell that, okay, you sit down somewhere and observe just with your naked eye, you can see that everything is coming up and going down. And you can say that, okay, everything is revolving around me. Right? It is easy to say that. So based on that, he calculated and gave a geocentric model, which seems to be a logical conclusion you can drive around if you do not have excellent um, tools to do your mathematics or to do your tools like telescope to observe and come up to a conclusion. Just observing with the naked eye, it is very easy to conclude it like this. But later we know that it is not Earth is the center, Sun is at the center. We are all revolving around. I mean, it's not even in the center, but we are all revolving around the sun. So we will come back to that later. So geocentric model is proposed by Ptolemy around 100 CE. But after that, this area is slowly going into dark ages because of, people say that it is because of Christianity. I don't know what or maybe the reason. Church becomes very powerful. Then so that's what we see, and people in that area, probably some nice some kings take over that area, and they burned that Alexandria library. All this could be possible, but if you see for 1,000 years from this time till 1,200 years, you do not see this kind of major leap. You saw Archimedes coming, Pythagoras coming, Euclid coming. All these things, people were continuously contributing within that 500, 600 years. All these things were stopped coming from Greece. When the whole Europe falls into dark age. No inventions and discoveries. Yeah.
There is one movie, if anybody is interested, Hypatia, Hypata. As you know, she is an Greek astronomer.
Okay.
She was, she's claimed to be one of the first people to accept heliocentric model.
Oh, okay.
So whatever you just mentioned, that kind of perspective the movie is taken. Maybe it's just one perspective, but then whatever you said is slightly captured in that movie. If anybody is interested, you can try. That's a good movie.
Oh, okay. Yeah, please type it in that.
Yeah, I will do that.
Yeah.
Hey, Balaji, one question there. So in the Ptolemy model, Earth is still flat, right? Or did they accept differently?
No, spherically they accepted.
Okay.
But still church didn't accept.
Okay.
Church didn't accept for a long time. But even during the Pythagoras time, not Pythagoras, probably later. But the moment you see something circles around, right? You see that they have accepted spherical, because it's definitely you cannot have some square and it's coming up, right?
Yeah.
So at that time itself, they have accepted spherical.
Yeah, I just wanted to comment on that. Actually, yeah, what Sir is saying is right. Actually, since 1000 BC, actually, they've noticed that the Earth is around, and maybe even before that, so oral history. And across the cultures, even the Vedas and even the Bible, there was this understanding that the world was dome-shaped. But then what happened was there was a lot of infighting into what the interpretation meant. So then it was then people thought it was to be flat, but actually in the ancient they already understood that the earth was spherical. I'll
Yeah.
cite some nice sources.
Yeah. Thanks, Judah. Yes, yeah, it's long time, but then you don't talk about it usually when it is against church. That's why you see that little later, whoever argued that Earth is spherical, they were kind of noted down or imprisoned. The things started happening. But yes, in Tamil there's a Bhugolam. The word Bhugolam is talking about not flat, right? Spherical. If you see Pythagoreans themselves, they have talked about circles and spherical of nature. All these things are already recognized, but they couldn't exactly prove it. Right? This all was waiting till little later. But yeah, does it answer your question, Sanjay?
Yes, Balaji. Got it.
Yeah.
Yeah. No, I was of the opinion that church accepted Ptolemy's part more or less, right? At least from my high school history, I'm
Yes.
recollecting.
Yes,
Yeah.
because it's geocentric, right?
Yeah. But still, I was not sure, whether they accepted it as spherical or still they were believing it as flat. So I was just
Oh,
trying to correct that. Part.
Actually, the thing is, this church history, it's very complicated because what we understand as history is kind of influenced by what our immediate historians thought, like around 19th and 20th century. So the thing was, during that period, they didn't really do really good history. So in order to do good history, we have to look at the primary document. So there's actually no evidence that the church was against the spherical concept of the earth. So there's evidence that the early church has always took for granted that the planet is a sphere. And some church fathers argued that it was flat, but they were considered as heretical against the church.
But then recently we had a Pope issuing that statement saying that we apologize for we apologize for not accepting this Earth as spherical, and they issued a statement like that, right? Considering that considering Pope as the authority, probably we can take that church was against spherical Earth. But I don't know. Yeah, I have not gone through that church history. But one thing we are sure is definitely they were not okay with having sun as the center instead of earth as the center.
Understood, Balaji. Yeah. Thanks. Yeah.
Okay. But science continues in India at that time when Greek slips into dark age. So we now have come to common era, that is after BC AD. So we found that they found that in Bakshali, a village in present Pakistan, a mathematical manuscript on accounting and geometry and all was found out. So this is a tablet kind of thing which is written in a sand-based document. So it continues. And in India, of course, Buddhism was getting much rooted. Nalanda was established. Again, this is another state-sponsored, probably the first state-sponsored university. Nalanda was established in 427 CE. It is more a Buddhist vihara where they call it Buddhist Mahavihara, right? So where people can come and discuss on various philosophical ideas on Buddhism or other, even in fact, even they practiced how to bring up a good breed of cows. All these biological, chemical, and philosophical discussions have happened in Nalanda, which is now only you can see it was burned a little later. Not little later, even till 1200 it was there actively. After that, it became, I think it's burned, or there was a fire accident that destroyed it. So usage of zero. Zero was there before. I mean, not in the form that we know now, but somehow what happens? What happens when you have a length very little and all? In Pythagoreans, the idea of zero itself was not taken seriously, or they wanted to avoid, because the geometry that you see in Euclid's geometry, it's all about triangle, circle, square, all these details. This geometry, if you see, you can't have anything of size 0, right? You can't have a triangle with the area 0, or you can't have a line segment with the length 0. So 0 is something that you can't easily handle it in geometry. You have to go a little bit of abstract number system to handle 0, which was actively used in Indian astronomy and Indian algebra. In the name of Shunya, it was very well used. So origin of algebra in India was happening at the time. And continuously, if you see Aryabhatta in the 5th century Common Era, you see astronomical treatise by Aryabhatta, that's also was arrived in this subcontinent. And 7th century CE, we have Brahmagupta talking about his own rules, not his own rules, but he gave rules for multiplication and division and negative numbers. All this algebra and other astronomy was developing in India. And after that, I think India also slips into dark age. That's where I wanted to stop, because this dark age is something that is a long gap, around 1,000 years, right? After that, we call it Renaissance. So in India, I mean the jump from this Greek and Indian location, the inventions and discoveries go to Europe, especially Germany, Italy, UK kind of places. So that is where the next set of inventions and discoveries would start coming. But from this 1,100 or 1,000, sorry, 0 to 1,000 years, or 100 to 1,100 years, something like that in Europe. And after 5th century BC, after 5th CE in India, it's all, I would say, dark age. So why we call it dark age? Of course, there was a lot of things were happening. People were constructing huge churches across Europe. In India also, a lot of new architecture has come. People built big temples, Ajanta Ellora kind of caves, Mamallapuram's beautiful cave temple. And if you see in Karnataka, Belur Halabedu kind of places where we have beautiful architecture, all these things have come during this time. But if you see all these things, mostly in India related to religion, only big temples came. In Europe also, a lot of churches, huge architecture, beautiful architectures came. And also, if you see, even in apart from religion, apart from architecture, if you see art, right? Beautiful poems, great writings of Indian system. If you see, all these things come before 5th CE. If you take Veda, or in Tamil has a Aimperum Kappiyam, 5 epics, five whatever you call it, Aimperum Kappiyam, which is about Ilangovadikal's Silappadigaram, and then Manimegalai, and then all these other great writings came before 5th century. And then we have Ramayana, Mahabharata, and these great epics also came before 5th century. Similarly, here also, if you see, great inventions and discoveries in Europe became before this particular era. After that, it's only everybody worshipped. Sorry, it looks like all these things came around religion. All these inventions, discoveries are architecture, your beautiful poems and all related to religion only started coming in. In Tamil, you have Saivas and Vaishnavites. They wrote beautiful poems, but it's all related to worship, right? I don't know much about what happened in this art form during that period. I mean, especially poems and writings. But even if you take the different arts, it's all period. The main category, main feature of that period, right? So that's why I agree with that term. Only thing is there is no major thought process change. Inventions and discoveries, we are not just looking at inventions and discoveries, right? That's simple. There are several such inventions which will, which is not change in idea, right? But when you see Ptolemy's model, it gives a thought process, right? How Earth is at the center. He gives the whole world a thought process. How to think about the heavenly body. So if that kind of great contribution has not come, that's what we mean by Dark Age. Of course, there were people building huge cathedrals and temples, and beautiful architectures were all going on. But it was all in the name of religion or God, or kings are doing those things. Okay. So for this session, I use these following books as my reference. Zero, this book is very funny reading. You can try this. It gives a nice how Pythagoreans were against this book, against the idea of zero, how they were avoiding. And then, in fact, they were even punishing those who were talking about zero and all. So it was really, really difficult idea to digest for those specific to geometry, right? Because obviously it is very difficult to handle mathematically when it comes to geometry, but algebra, it can be handled very easily. So zero, this book is a fun read. And of course, these books are serious historical, it has some historical depth in it on various inventions and discoveries. So that is what I wanted to discuss today. Any question?
Just a fun thought is if Pythagoras had wanted to name zero, he would have named as unnatural number possibly, because
Probably, yeah.
because natural numbers we know it starts from 1.
Yeah,
It
yeah,
goes.
yeah.
So if he wants to name zero, no, just for a thought like irrational.
Like irrational, right? Like irrational.
Yeah, correct. Yes, yes.
Mhm.
So fantastic it was.
See, one thing I'm very surprised, or what to say, yeah, surprise is the word I can say, is to see that how biased these scientists also are. So we all think that science is very rational thought process, and they will be unbiased, and they will be absolutely look from the truth angle of view, right? But it is very, very continuously we can see, including Einstein, we will talk about that later. that they wish something and they want to see it. And then if it contradicts, they try to even don't accept that. They even try to contradict the experimental output itself, right? So like that, see, Pythagoras is averse to this irrational number and zero. And later point of time, Einstein not believing in quantum mechanics. Newton is always against wave theory of light. All these things we see, these scientists were also like us, were simple biased human beings. Of course, they were genius, but they also had that bias is what I'm trying to tell. So that's what something I see when I read about them.
That's true. That's true. We see that. Yes. Maybe in our case, it's more dominant. At least they have slowly started relieving themselves of such inhibitions, possibly.
Yeah, yeah.
So I wanted to say one small thing. Uh, the so-called Dark Ages was a phenomenon, I think, predominantly in Europe. So while the Dark Ages was happening, actually there was a flourishing of Islamic science. Islamic science, in the sense that what was happening was all this knowledge from the East, that is China, India, and even the Middle East,
Mhm.
they were synthesizing knowledge across cultures, that is from the East and the West. And they were storing the knowledge and doing new stuff. So, for example, Avicenna synthesized the canon of medicine, and he's a Muslim scholar. So, all of this was also happening during that time. So, the Dark Ages wasn't like completely like nothing was not happening in that period. And they helped the flow of the knowledge of architecture and everything like that.
No,
So
definitely. That's
yeah.
not exactly our next session. So what
Okay.
happened during that time, and how the zero or algebra reached Europe through Islamic age. But even if you take that as a, what to say, things are happening, but the question was what is the major breakthrough was the question, right? So that's why they call it dark age. Things are happening, I totally agree. But what is the path-breaking thought process or major? Probably it was waiting for this science to reach there, right? But then why this science stopped happening in these areas where it was already flourishing? So that's where the question of the stagnant comes in, right? So yes, Islamic world took took Indian science and Greek sciences. They translated to Arabic and then to Latin. Then it became accessible to Europe. But the Greeks had huge tradition, right? Big tradition, great tradition. India had big tradition. Where did that go? So that's what I think that's what they call it, dark age, because of certain. Probably India caste became very uh, what to say, a dominating factor, or Bhakti Marga, right? Bhakti became a major tradition than scientific queries. So that's why you see Alvas, Nayanmars, Saivism, Vaishnavism, Jainism, all these religious categories, they started probably having serious fights and scientific queries lost in that thing. I don't know. These are all, maybe we have to talk to a good historian. Yeah. So next class we will talk about how did Europe emerge from Dark Age and what triggered it, and take it from there. It was nice to see comments from Prasanna and Judah, it is very helpful. Any
So
question?
we enjoyed a lot actually seeing the.
So earlier, yeah, it is like that's what during my childhood, when I read about science, suddenly somebody from Greek, they have told, actually these things should be there in our textbooks to make it little more interesting. Suddenly somebody from Greek, something will come, and somebody from Italy, something will come. So we will not know why a Greek is himself or herself would have not told this thing, and why they waited for some long time. What didn't happen? So these things, this simple history of that something happened and then it stopped. Then the idea of science moves from one geographical location to another place. It emerges there. So then happens there and then move to somewhere else, right? It keeps happening. So that kind of thing was not given. And then we fall to trap of this glorifying a particular place, like somebody will come and say that, oh, in India, everything we already told, even plastic surgery was there. All these things they will tell, and then we say, oh, wow, we were so scientific. And then if we ask what happened now, people will not have answers.
Just one, by any chance, is Surya Siddhanta, will you be, touching at any point?
What is that?
Surya Siddhanta, it is claimed to be the around 500 BCE. That's the first text, at least the still existing text, which talks about astronomy in
Oh, is
a
it?
sincere. Yeah. Bhaskaracharya is the acclaimed author.
Bhaskara.
Bhaskaracharya is the
Okay.
claimed author.
No,
Surya
no,
Siddhanta.
I didn't come.
Oh,
Maybe, yeah, I didn't come across that.
okay.
Bhaskaracharya or Bhaskara, right?
No, Bhaskaracharya is the
Bhaskara
author.
and Bhaskaracharya is different.
Yes. Yeah.
Okay. Yeah, because Bhaskara is 12th century CE.
Correct. This guy is BCE.
Oh, okay. Yeah.
Correct.
Oh, please
Because all
share it in that group.
I will do that, because Aryabhatta and other people seems to have taken over from the Surya, and they have improved upon with the current knowledge then in 5 BC,
Oh,
5 CE.
okay. I didn't know. Okay.
More than for the knowledge sake, just to see how historically things have been thought about and progress, just to have a feel of that only I was mentioning it. Yeah.
Okay, sure.
Okay. I'll share that. Yes.
Yeah.
One more small comment is that apparently Babylonians had a understanding of Pythagorean theorem way before Pythagoras.
Mm-hmm. Okay.
So Babylonian mathematics, like it's hard to understand because they have a very different notation, but
Mm-hmm.
they've also done a lot of complex astronomical
Yeah.
work that we're
Yeah.
still trying to understand.
Mm-hmm. No, definitely there are certain things like what to say, a particular idea we see as one person developed, but before that, lot of people had that idea. But probably one thing is that we put as a document and claim it, right? I don't know. I don't know whether you have heard about this. For example, evolution theory was arrived by Darwin and another person. I don't remember.
Wallace.
Yes. So almost Wallace would have published it. Just before that, Darwin urgently had to publish to claim it, right? So multiple people, in fact, even before Darwin and Wallace, people had ideas about this. Somehow they didn't publish it, and somebody has to take that risk of publishing and getting the wrath of church, right? So Darwin took it and did it. So probably like that. There's several I keep seeing like this. Several such ideas were existing, but then one person claims it because that he or she has documented and gave it to the world. Judah, is this your first session?
Actually, I'm unable to join on Saturday because Saturdays is the busiest day for me. From
Okay.
morning to night, I'll be working because of the work demands. So I did
Oh,
attend, I think, first session. This
okay.
is
Okay.
the second session.
Oh,
But yeah,
okay. Okay.
yeah, I'm unable to attend on Saturday, sir.
Okay. Okay. So looks like you have done a lot of reading on this science history. Just trying to see in what way you can contribute.
Oh,
Or you-
definitely. I really love science history, mathematics history, and currently I'm actually most interested in economic history. I'm
Okay.
trying to understand like what exactly is the problems in our world and what are the root causes. So I
Mhm.
feel like it's something to do with capitalism and the way we are without restraint we are pursuing progress.
Okay. Oh,
So that's
excellent. Okay. Sure. Hey, Prasanna, you also had done some historical reading on science, right? So people are welcome to take 1 or 2 sessions.
Yeah, sure. Mine is more into mathematics side. Yeah, definitely we will do that. Yes. Yeah.
Yeah.
Maybe I will touch upon music and mathematics some whenever we have
Okay.
a we have a window. I will do that. Yes.
Oh, sure. Yeah.
Yeah.
Excellent.
I
Thank you. Yeah. You were saying something?
I'd love to guest present.
Sure. Yeah. So if you have some kind of course in mind, put together, let us do it. We can. History is always interesting, fascinating. Yeah, we'll do it. Okay. Anything else?
I mean, just enjoyed the morning.
Thank you.
Yes.
Thank you. Have a good
Yeah.
day. Take care.
Yeah. Thank you. You too. Yes.
Bye.
Thank you. Take care.